Welcome back to the channel and to our 1989 Chevy S10 diesel swap project. I'm Jimbo and I'll be your narrator in today's video. I am in fact 100% human and I do make mistakes, as you'll see later on in this video. But no worries, this project is still on course and we'll be firing up this diesel engine real soon. Today, we're going to cover the cost of doing this engine swap, and since this project does require a fair bit of fabrication, I'll provide a close-up of every part we built and I'll rate them on a scale of 1 to 10 as far as difficulty in fabrication. I think you'll be surprised at both the cost and the level of difficulty. Now, if you haven't watched any of the previous videos, well, you really should. We go into a lot of detail on how every part was selected or fabricated in this unusual engine swap. Now, the goal is to get this 1.6-liter normally aspirated Volkswagen diesel engine to power our semi-vintage Chevy S10 pickup truck. So the first hurdle we had to jump was getting the Volkswagen engine to bolt up to the stock Borg-Warner 5-speed transmission that came with our pickup truck. This transmission was originally bolted to the Iron Duke 2.5-liter gasoline engine when the truck left the factory 36 years ago, and now it's going to be bolted to the Volkswagen engine with a kit that makes all the doohickeys line up, and I'll show you how all that stuff works in a moment. So the engine that we're using is one of the many variants Volkswagen produced over the years, and this engine's a 1.6 liter and it makes only 54 horsepower. However, bigger displacement engines with significantly more power are available either with turbos or naturally aspirated. Of course, I would like to have a more powerful engine, but this little 1.6 liter engine was free and it's a good runner. So that's what we're starting with. The good news is nearly all the purchased or custom parts that we have will transfer to a more powerful engine if we're lucky enough to find one in the near future. Anyway, this table full of parts is pretty much what it takes to stuff a Volkswagen diesel engine into a Chevy S10. Now, since the frames on the first gen S10 and the second gen are exactly the same, it really doesn't matter what year S10 we used. But I like the way the older square bodies look, and they're a few pounds lighter, so that's why we went with a square body. Now, the truck we chose for this project was probably the worst S10 we could find as far as rust goes, but it was exactly what we wanted. It was a short bed with a manual transmission and it had absolutely zero options. A simple, basic, no-frills truck. As you can see, this truck is no longer rusty, which was no easy task. We had to replace both front fenders, the hood, both doors, both rocker panels and cab corners, and we slapped in new floor pans. The truck, it's not perfect, but it definitely looks a lot better. Anyway, back to the parts. In order to mate the Volkswagen engine to the Chevy transmission, we used this transmission adapter kit. Now, we paid $1,300 for this kit, which at first seems expensive, but in the past, I've made my own engine to transmission adapters, and let me tell you, $1,300 is cheap. Building something like this from scratch is not easy, and I can truly appreciate the engineering that went into these parts. You know, dreaming about building something like this fuel-efficient pickup truck doesn't get you anywhere if you can't build the parts, and this kit is the way to go. Now, this kit was designed for the Volkswagen ALH TDI engine, but it works on the lesser endowed engines, and it was the key to getting this project started. Anyway, I paid full price for this kit, and I didn't get a YouTube discount. However, if after watching this video you're inspired to build a similar project, then use the link in the video description. That way I can earn a few bucks. The folks who made this kit also make kits for Ford, Jeep, Toyota, Suzuki, Nissan, and others. So you're not just limited to doing an S10. So keep in mind, when using this transmission adapter kit and the original transmission, you don't have to fiddle around with the drive shaft or the transmission mount. That stuff remains the same and just use what was already on the truck. Anyway, in order to get this kit to work, I also had to purchase a flywheel for a 2.8 liter Chevy V6. This flywheel was $68 on Amazon, and it's a Luke part, so it's decent quality. I also picked up a clutch kit for $102. This kit is for a Chevy S10 with a 2.2 liter, a 2.5, and a 2.8 liter engine. Apparently, they all use the same clutch assembly. Now, when it comes to the motor mounts, well, first of all, we're using the stock Iron Duke frame mounts, and those didn't cost us anything because that was already on the truck. We just painted them to look new. However, we did have to fabricate the left and the right mounts that bolt to the Volkswagen engine. So the fabricated engine mounts were made from scrap 1/4 inch and 3/16 inch steel, and it didn't cost us anything, but figure maybe $50 worth of metal if you had to buy the raw material. I'll show a close-up of how these mounts fit in a few moments. The oil pan was custom fabricated in-house. We used the stock Volkswagen Rabbit oil pan as the base and then modified it to clear the chassis crossmember on the truck. Plus, we also added a sump to it to make up for the lost volume. So the Rabbit oil pan was $35, the 16-gauge steel that we purchased was $36, and the drain plug was $8. We did buy a Chevy 4.0-liter V6 oil pump pickup and used a section of that to modify the stock Volkswagen oil pump pickup. The Chevy part was $24. Now, the welding was done by a friend of the channel, however I did pay $100 for the service. So at the end of the day, the oil pan costed $203 to construct. Now, the intake manifold that we're using is from a Volkswagen Jetta gasoline engine. This manifold was sourced from eBay for $60 with free shipping. It fits the engine perfectly and it allows us to experiment with a turbo down the road. You know, there are a lot of choices when it comes to intake manifolds, and the Jetta manifold was the right one for us. The exhaust manifold, well, it's a generic cast iron turbo manifold that was made for a Volkswagen 8-valve engine, and it was $95 on eBay. And the best part is, it puts the exhaust in the right direction and provides us plenty of clearance for the starter. The downpipe we fabricated is made up from several pipe sections, and it cost us about $150 in material. This custom downpipe will connect the Volkswagen engine to the stock Chevy exhaust system, which on this truck was relatively new, so that pretty much takes care of the exhaust system. And finally, right here is the solution for the water neck on the back side of the cylinder head. So on the rear of the cylinder head, the water neck fits like this, which is a problem because it points the heater hose directly towards the firewall. So I grabbed the water neck from one of my Kubota D722 diesel engines, and boom, it fits perfectly. And it gets the heater hose pointing in the right direction. This part is something I already had in stock, and they can be expensive. However, you can get them on eBay for $25, which ain't bad. Anyway, as far as parts go, we've spent about $2,000 for all the stuff required to bolt the engine to the Chevy chassis. Now, we still have to replace a bunch of gaskets and the timing belt and a few odds and ends. So realistically, the nickel and dime stuff adds up pretty quick, and I'll say another $700 will cover this, that, and the other thing. I think that's actually a pretty close estimate. So at the end of the day, you're looking at $2,700 to do this engine swap if the engine's free. If you have to buy an engine, well, duh, that's more money. But figure if you shop around, you can get a whole car for about $1,000 or so. So if that's the case, sometimes you can pull the engine and you may be able to recover some of the money by selling off the parts you don't need. So our cost is going to be around $2,700 for the engine transplant. Now, if you didn't know this, that's actually cheap for a project like this. I've done plenty of engine swaps in the past and they're not cheap to do, especially when the engine and the transmission were never meant to be together. Hopefully this answers the question on the cost. Now, like I mentioned earlier, there's plenty of fabrication involved, so let's take a look at how difficult it is to make some of these parts. The transmission to engine adapter kit is pretty much a bolt-together affair, but you do have to modify the transmission bell housing to provide clearance for the starter gear. This modification is kinda simple if you use the correct tools. So the starter fits this aluminum plate like this. You actually get a few options on the starter placement, and this is what works best for our application. Now, when this aluminum plate is bolted up to the bell housing, you can see on the back side we'll have to carve out a small section in order to clear the starter gear. Now looking at the front side, basically we're going to have to hog out this section. Now I went ahead and 3D printed a template to sort of give me an idea where I'll do the cutting. Now this template isn't necessary, and the reason I made it is I couldn't find an example of what people actually did. So if you're watching this video, this is an example of what you need to do. Leave it up to Robot Cantina to actually document what needs to be done. So basically, we need to take a chunk out of the bell housing in this area. You want to remove enough material so the starter actually fits, and we also have enough clearance for the starter pinion gear when it extends. Of course, I went ahead and 3D printed a model of the nose of the starter with the pinion gear extended. Again, this isn't necessary, it's just something I did to make things easier. Now, the instructions say to use a die grinder to hug out the aluminum, so let's give that a shot. Well, this sucks. The die grinder gets clogged up pretty fast and it stops cutting. It turns out the fastest way to do this is to drill a hole first. The bigger, the better. Then use a cutoff wheel or hacksaw to cut through the thick stuff. And this is going to be a lot faster by many orders of magnitude. Now for the rest, perhaps the die grinder would work, but I went ahead and used hand files to shape the cutout to the size I needed. Fast forward a bit and we're done. The hand files worked great for this mod, and if you don't have a die grinder, no worries. Grab a drill, a hacksaw, and some files. The 3D printed part fits with plenty of clearance. Now keep in mind, this part is a model of the starter with the pinion gear extended. Now just for fun, let's test the starter and see if there's going to be any problems. Yep, it works. Not too shabby. Alright, let's give this a score as far as difficulty. On a scale of 1 to 10, 10 being the most difficult, I give this a 2. Now, I know some of you guys eat carburetors for breakfast, and this is not even a 1 for you. But figure it like this, if you have the basic skills to change the oil on your Subaru, and it still runs afterwards, then this would be a 2 for you. If your Subaru doesn't start after changing the oil, well, perhaps this isn't a project for you. Let's take a look at the fabricated motor mount for the right side of the engine. So this guy was about as simple as it gets. Right here we have a 1/4 inch thick steel plate, and on top of it we have another 1/4 inch thick steel plate that we're using as a shim. Over here we have two fabricated spacers. One is a 25mm and the other is a 30mm. You know, I reckon you could buy these from like McMaster Car or somewhere else. Now over here is the engine mount from the Iron Duke engine, and it was slightly modified by trimming a small section off, but basically it's a part we already had. So these parts fit the right side of the engine block and is secured by these 4 bosses. Now, how I determined where the mount should go was to actually place the engine in the truck with the transmission mount in place. Then I just lined everything up. This side turned out to be real simple. Now it should be noted that on a Chevy S10, the center line of the crankshaft to the chassis is offset by 1/2 inch. This is how the factory assembled the trucks when they were new. On this mount, our offset is slightly more and we have an additional 1/2 inch. And that was due to space limitations, and that was the best we could do. Anyway, with this simple engine mount, we were able to use the Iron Duke rubber frame mounts, and basically this side of the engine will bolt directly to the factory holes in the frame of the truck. So building this frame mount takes very little effort, and all I used was an angle grinder and a drill. Of course, I had to measure a lot of stuff, and that's kind of expected. I would rate this as a 2 on the scale of difficulty. This was by far the simplest motor mount I have ever made. So let's see how difficult it was to make the left side motor mount. The fabricated motor mounts for the left side of the engine is actually semi-simple, and it consists of these 2 parts. Now the good news is, these parts will allow us to use the original Iron Duke frame mounts. So given that the transmission mount is the same, the right mount is the same, and this motor mount is the same, this engine and transmission can bolt up to the Chevy frame exactly like the Iron Duke. Now these 2 brackets bolt together like this, which makes it really easy to install on the engine. Now I took this to the next level, and I also incorporated the original alternator mounting bracket into this mounting system, and it fits like this. The cool thing is, all this crap pretty much occupies the same space, yet we can still use the factory frame mount. So these brackets were easy to make, and there's nothing special about them. I would rate these about 3 on the difficult scale. The hard part was figuring it all out, and that took the most amount of time. But a little time spent thinking things through will often save you a lot of time in the end. Let's go ahead and slap these parts on the engine. The left side of the engine is complex because there's a lot of stuff that's going to get in the way. So on this engine, we have 6 attachment points that can be used. 4 of these attachment points are going to be shared with the water pump. Now the water pump fits the engine like this, and these are the 4 holes we'll be sharing. In theory, this works out to be plenty of bolts to take up the weight of the engine. But as I was filming this segment, I did discover a major problem. You see, this aluminum water neck is attached to the water pump backwards, and that's perfect because this way it'll allow the radiator hose to go in the correct direction. Unfortunately, doing it like this will put a hole in the water neck once everything's bolted in place. And it turns out, this unused nub on the engine block pokes into the water neck. The good news is, well, I don't need this nub for anything, and I can grind it off to provide the necessary clearance. But I can't do that until the oil pan's back on the engine. The last thing I want is to get grinding debris inside the engine. That would suck even worse. So for now, we're going to pretend this issue's been solved. This bracket has an unusual shape because it has to provide enough clearance for the cooling hoses and the dipstick, and it's going to bolt to the engine block over here. I actually made this bracket in 2 pieces, then welded them together to get the correct angle. In theory, this was the prototype bracket, but it turned out to be good enough to be used. With the bracket in place, I still have plenty of clearance for the dipstick and the upper cooling hose. Those parts have already been test fitted with no issues. On the bottom of the bracket, I also have plenty of clearance for the heater hose. Like I said, there's a lot going on in this area. Next, I can install this bracket on top of the water pump. Now, the water pump on this engine was designed to handle a huge load, and normally the water pump housing has to carry the load of the alternator, the air conditioner, and the power steering pump. So I think it's safe to use this as a motor mount location, especially since we'll be using the alternator bracket to reinforce this area, and that bracket actually transfers part of the load to 2 more bolts on the engine block. This truck doesn't have power steering or air conditioning, and that's fine. And the motor mount is in. As I mentioned, this took a bit to figure out, and I'm stoked that I was able to use the original Chevy frame mount. Off camera, I've confirmed that the hoses and all the other stuff fits, and this is how the left motor mount looks when it's installed. You know, I'm not 100% sure that this side of the engine is the same on all the variants, and I may have to make some changes if I upgrade to a more powerful engine, but I suspect the changes will be minor. Let's take a look at the oil pan situation. This is the hacked up oil pan that we used in order to engineer the motor mounts and basically everything else in the truck. This guy determines exactly how the engine will fit in the engine bay, and it was the very first thing we built once the engine was dropped into the truck. Obviously, this thing won't hold a drop of oil, but that wasn't the plan. Once we sorted out everything else in the engine bay, then it was time to measure what was left of the oil pan and build something that would actually fit in the space we had left over. Now, this is the finished oil pan, and the shape is a little bit odd, but that's fine as long as it fits. Now, we did put a turbo drain on this guy because, well, turbo! However, we won't be doing the turbo right away. First, we need to get the truck back on the road. So I tack welded a few parts onto this pan and then set it out to be professionally welded. All the welds that were done by King Precision Machining were perfect, and the only weld that leaked was one of mine. So I think it was a good call to send this thing out. This pan took 4 hours to fabricate as far as the sheet metal goes, and I did it with a hammer, an angle grinder, and a vise, so no special tools were involved. On a scale of 1 to 10, I would rate this as a solid 8 as far as difficulty. Now that's an 8 for me because this sort of sheet metal work is not something I do every day. You know, after looking at the finished result, I think I could have done a better job, and perhaps next time I do something like this, I'll at least have a little bit more experience under my belt. Anyway, the modified oil pump pickup fits the pan like this. This pickup is pretty simple to make, and it uses a section of a Melling 2595 pickup in order to make the 180-degree bend. This part was also welded by professionals, so it's hard to say how difficult it is to make. As far as piecing it together, well, it's a 1 or a 2. The welding aspect changes that depending on your equipment and your skill level. So this is the stock Volkswagen oil pan that was on the engine, and it was built with the intention that the engine would be on a 15-degree slant when it was in the Volkswagen Golf. From what I can gather, this pan should hold a little bit more oil when the engine's mounted straight up. So we're going to do an experiment and see what the difference is between the stock pan and the modified pan by adding a gallon of water to each pan and then measuring the level of the water. Hopefully we didn't lose much volume with the modified pan. So let's start with the stock pan first. Now I'm going to be adding exactly 1 gallon of water to the pan, and we'll measure the distance from the rail of the pan to the surface of the water. Now in theory, this stock pan should hold way more than a gallon of oil when the engine is standing straight up. Alright, let me measure that. So it looks like from the rail to the surface of the water we have exactly 1.5 inches. Well, now we know. Let's try this again with the modified pan. So this ruler drops down into the water about 1/4 inch. Now that tells us this pan has slightly less capacity. So let me scoop out some of this water until the level is at 1.5 inches, and that'll tell us the difference in capacity. Well, it looks like there's a little bit more than a 600 milliliter difference, which is a little bit more than a half quart. The good news is, once you factor in the fact that the pan is level and not on a 15-degree slant, we're probably pretty close to the oil capacity of the stock Volkswagen engine. You know, it would have been nice to have more capacity, but this is going to be just fine. If I were to make another pan in the future, I think I could actually increase the capacity a little bit, but like I said, this is going to work just fine. At this point, I have enough parts purchased or built to mount the Volkswagen engine in the truck. The degree of difficulty on this engine swap is based on a lot of factors. The parts that I fabricated were simple to build, but keep in mind I also spent a lot of time deciding what the simplest solution should be. And every decision I made had to include how it would affect the other decisions. In a way, it's like putting together a three-dimensional jigsaw puzzle. In this case, there's probably a lot of other solutions. I chose the simplest and most cost-effective solutions. So speaking about cost, this engine swap is not the only thing we're doing on this project, and my desire to keep costs down will make sense in a moment. So we started this project with a no-frills, dilapidated pickup truck that was ready for the scrapyard. And when you add up the cost to purchase the truck, then transport it to the shop, then replace all the sheet metal, score down some paint, we're at $2,200 so far. This truck still needs a few interior pieces and some odds and ends, so basically when we're done with this truck, it'll have costed us $3,000. Now on top of that, we have the $2,700 to do the engine swap. So we're into this project for about $5,700, which for a small YouTube channel that doesn't have sponsors, that's a fair chunk of change. The good news is, between my patrons and the revenue this channel generates, we're able to do projects like this and still keep the lights on. I really try to maintain the high quality to the builds and to the videos I produce on a very small budget. Now, fortunately, the labor was all free. However, if I factored in the cost of the labor to build this contraption and the labor to produce the videos, that's where it gets really expensive. You know, it's hard to put a price on the labor because in my case, I have to consider the cost of producing the videos and the extra time it takes to document everything. If I didn't film any of this stuff, well, the project would have been done a long time ago. Making videos is fun to do, and I'm glad I have an audience willing to watch. I really appreciate the subscribers that tune in every week, and of course all my patrons. Please consider subscribing if you haven't done so already. This week, well, the engine was supposed to go back in the truck, but we had a minor delay. No big deal. We'll get the truck running and driving real soon. Looks like I have a lot of work to do in the next 7 days, so it's time to brew a pot of coffee and dive right back into this project. We'll see you next time. Until then.